find the horizontal and the vertical asymptotes of the given curve. And right, so over here given as 5x squared plus x minus 5 and everything that divided by x squared plus x minus 72. So in this example our goal is to find the horizontal and vertical asymptote for this curve. So how can we find that? So let's first focus on how to find the horizontal asymptote. Okay, so our goal is to first to see if we can find the horizontal asymptote for the given curve. And how can we do that? By the definition, to find the horizontal asymptote, what we can do is we can evaluate the limit of the function. So in this case 5x squared plus x minus 5 divided by x squared plus x minus 72. So we need to evaluate the limit of this function at positive or negative infinity. So if we try to see if we can find the limit at infinity or negative infinity of this function, if that limit exists and it turns out that is equal to some finite number, then actually y equal to that number will be the horizontal asymptote. So if that is the case, why don't we just evaluate this limit? But how can we do this? Let me just focus on how to find the limit at positive infinity. Okay, and then we can do the same process and then try to figure out the limit at negative infinity. Okay, so let's do this one. So this is a rational function given over here. How to find the limit at infinity of this? There might be a couple of ways, but I just want to focus on for a moment on simplifying this expression over here. What I want to do here is on this given rational function, I want to see what is the highest power function appearing over here to the top and bottom. I see there is x squared, right? So that is the highest power function, and I want to use that highest power function x squared to divide the numerator and the denominator. So if I want to do that, you can see here this can be done by 5x squared divided by x squared plus x over x squared minus 5 over x squared. When I use that to divide the top, do the same thing at the bottom. X squared divided by x squared plus x over x squared minus 72 over x squared. Right now I'm just focusing on let's say a little bit rewriting the given function. Okay, now I am dividing here by x squared, right? And then now if I simplify a little bit, you can see x squared common factor, we can cancel that out, and then we can little bit simplify the first term, which will be 5 over here at the top, plus here I have x over x squared, right? On the second term, if you simplify that, we'll get 1 over x minus 5 over x squared will be at the top, and then divided by 1 plus and then you can see x squared divided by x squared will be 1. X over x squared, when we simplify that, will be 1 over x minus 72 over x squared. So that's how I try to little bit rewrite in a different form for the given function. Now you can see here when I do that, when x gets larger and larger, the 5 will be always 5, right? The constant will be always constant. But when x gets larger and larger, 1 over x will approach to 0. 5 over x squared will also approach to 0. 1 will be always 1, but 1 over x will approach to 0. 72 over x squared will approach to 0. Wow. If that is the case, then I know that the limit of this function at infinity will be 5 over 1, and that is just equal to 5. And that's how we are able to find the limit at infinity of this function. So, and that limit exists, and we are able to calculate that. If you try to find the limit at negative infinity, I believe you will get the same thing over here. You can try that, but it turns out that if this is the limit at infinity, then y equal to 5 is the equation of the horizontal asymptote for the given curve. Horizontal asymptote for this given curve. Okay, so that's how we can find the horizontal asymptote. But to find the vertical asymptote, you can again use the definition of the limit, no problem with that. But if you want to use the limit definition, we need to see when x gets closer and closer to some number, we need to see if the function gets larger and larger or smaller and smaller. If that happens, then we get the vertical asymptote. But to find those numbers, it will be really little bit challenging. So what I want to do here is I just want to factor the denominator. So the given curve is 5x square plus x minus 5 over x square plus x minus 72. Let me factor out the denominator. When I do that, this is quadratic, so x and x I can get it, right? So I now need to think two numbers whose product is negative 72, but when I combine I need to get x. How is that possible? Positive 9 and negative 8 would work, right? So I can do that, and let me write down the top as it is, 5x squared plus x minus 5. So this is how I can just factor the denominator. But now you can see that when I factor, I saw that the denominator, you can see x plus 9 plus, and then x minus 8. That's how I get it here. When I set that equal to 0, it turns out that at x equal to minus 9 and x equal to 8, right, the denominator is 0, right? So what I'm trying to see is actually where this denominator is 0. It turns out that x plus 9 times x minus 8 is equal to 0 if from here I get x equal to minus 9, and from here x equal to 8 are the two numbers where the denominator is 0, right? But exactly at those two numbers, if you check the numerator, actually the numerator, if you evaluate that at these two numbers, let me replace x by negative 9 at the numerator, and then plus negative 9 minus 5. This is not equal to 0, right, at negative 9. Not only that, if you replace 8 at the numerator, then also you can clearly see this fact over here, 8 minus 5. So the numerator is not equal to that at that location. So if that happens, that means if the denominator is 0 at certain location, but the numerator is not, or the top function is not 0 at that location, then those are the vertical asymptote. Those are the location where you have the vertical asymptote. To check that, you could literally try to see what is the limit of this function, okay, this given function. When x gets closer and closer to, let's say, negative 9, you can try what is the left side limit of this function, what is the right side limit of this function. Okay, you can try that. So let's say this is the given function f of x, okay, and f of x. Try these, or you could also try what is the limit of the function at a from the left or from the right. Try that, okay. Evaluate these, any of these limits are 4 or whatever you want to try this one, okay. I believe that you will either get positive infinity or negative infinity. So if that is the case, we can clearly conclude that x equal to negative 9 and x equal to 8 are the vertical asymptote for this problem. Okay, so if you have a rational function, then it's very easy to find that, right? So we just need to see where the denominator is 0. Those are the locations where maybe they are the vertical asymptote, but to confirm, you just plug those number into the numerator, okay, and then see if at that numbers, if the numerator is not 0, the denominator is 0 but the numerator is not. If that is the case, then those will be the vertical asymptote. But you can also apply the definition of the limit over here to check at these numbers, either left side or right side limit, or the limit if that is infinity or negative infinity. If that happens, then also it will be the vertical asymptote. So this is how we can find the horizontal and the vertical asymptote for the given rational function.